We're going to solve some systems now. This time we'll solve systems of two equations and two variables. This is the most basic setup. When you're going to solve the system, then you want the x's and the y's and the constants to all line up. And once you have that, remember the first step, and again, this was the way that worked for all systems, or at least systems of two equations, but it's not necessarily the only way to do it. But the first step is to flip-flop the first two numbers. So we're going to multiply the top by 3 and the bottom by 2. And again, we're going to multiply the entire equation by those things. And so what we'll end up with is 6x minus 9y equals negative 3, and 6x plus 2y equals negative 14. And the reason for doing that now is that the coefficient of the x term is 6 in both, and so now I can subtract the two equations. Make sure that you subtract the entire bottom equation, not just the 6's. Okay, so when we're doing subtraction, I'll go through it. So we got 6 minus 6 is 0, so the x's are gone, and that's exactly what we want. Then we have negative 9 minus 2, so that's negative 11y, and negative 3 minus negative 14. So minus minus becomes plus. Negative 3 plus 14 is 11. And then I can solve for y. And so y equals negative 1. Now once I know that y equals negative 1, it's negative 1 for either of these two equations. So to solve for x, just plug that back into one of the two equations. I'll take the bottom one less number to worry about. So 3x plus negative 1 equals negative 7. 3x minus 1 equals negative 7. And then just go through the steps to solve. So x equals negative 2. And so now I have the solution to my system. X is negative 2, y negative 1. If I want to write it as a coordinate, remember x comes first. And so that would be the answer as a coordinate. You may see the answer as a coordinate on the multiple choice test. There is a way to do these on the calculator rather quickly. Using the matrix commands. And so I'm going to show you this on the calculator right now. What you have to do is you have to use the matrix menu, which is second and then this x to the negative 1. What we want to do first is we want to edit. And it doesn't matter which matrix you use. I always choose A because there's no reason not to. It's the fastest to get to. And a matrix, the first things you see at the top are what are called dimensions. And it's the number of rows times the number of columns. And the way you can think of it for our problems is it's the number of equations by the number of variables. So, the number of variables plus whatever they're equal to. So number of variables plus 1. And you'll see why in a second. So we have two equations. And we have two variables plus 1 is 3. So it's kind of two variables plus the answer. And you can see why it works that way because now you have 1, 2, 3 spots to fill in, and we have, 1, 2, 3 numbers in a sense to fill in from the problem. So let's just fill them in. 2, and you can just hit enter and it'll automatically take you over there. Negative 3, make sure you get the signs in there. Negative 1, 3, 1, and negative 7. Now I wish they had an easier way to do this on the calculator, so it seems like a lot of steps, but once you get it down, it's actually a lot faster to solve this way. So you have to quit out of there and then go right back in, but this time we want to choose math. And what we want is we want to go down to RREF, which stands for Reduced Row Echelon Form, which I'm not exactly sure what it means. I just know what it does. I don't even know what an echelon actually is. Or you can just choose B if you want. And now you have to tell it what matrix do you want to do that on. Well, we got to go back to the matrix menu, but this time choose names, and we want our matrix A that we just created. And what that does is it kind of solves the system for you. It's coded, but if you see the answer sitting right here on the page, you can probably tell what the code is. If you notice when we type things in, the x variable comes first, then the y variable, then the answer. So what this is telling us right now is 1x plus 0y equals -2. Well, 0y isn't really part of the equation, so it's saying 1x, or just x is -2, and y is -1. So if you type this incorrectly, the way you read it is the top number is x and the bottom number is y. So there's our answer, -2, -1. And then that's another way either to check your answer or just to be done with the problem. All right. Let's try another system. And the reason why I put this system in there is just to note that it is not lined up yet. So there are some systems you're going to get that you can't just start working on right away. You have to look at them and make sure that they're lined up. So here, the bottom system, or the bottom equation, is set up the way I would like it to be, but the top equation is not. So how can I make it look that way? Well, let's just move the 3x over to the other side. The y is on the right side. And remember, when I move something, all I'm doing is changing its sign. So -3x plus y equals 8. So now that equation is fine. Let's pop the second equation right underneath it. And now, do the same steps. So multiply the top by 5, the bottom by -3. And subtract. So again, the -15s cancel. Some of you, by the way, have done this by changing this sign so that you can add instead of subtract. That's fine. Just make sure at this step you remember to distribute the signs correctly. But anyway, so I've got 5 minus 6, so -1 or -y equals 40 minus -9, and that would be 49. So then y equals -49. And x, let me just make sure I did that right. That seems like a rather large number for a problem like this. Nope, but that's what we get. So if that's what we get, that's what we get. And then let's plug it in for the other equation. So I got -49 equals 3x plus 8. And here you can actually go back and plug it into the equation that you started with. You do not necessarily have to plug it into one of these, although it will work just as well. And so subtract 8 from both sides. -57 equals 3x. Whoops, sorry. And x ends up equaling negative, I think that's 19. And so there's our answer. X equals -19, y equals -49, and we can actually check that on the calculator to see if we got it right using the same method as we did before. Here's a third type of system. This one doesn't look any different off the bat, but there's a reason that I put it in, which I will show you. So let's multiply the top by 3 and the bottom by 6. And so I get 18x plus 6y equals 30, and 18x plus 6y equals -30. And if you notice here, both these numbers turned out to be the same. And remember, there's two options when that happens, because when they both turn out to be the same and I subtract, both of them go away. So I'm left with 0 equals. But now I've got 30 minus -30. So minus a negative becomes a plus, so that's 60. Well, there's no more variables left. Well, this system is trying to tell me that 0 is equal to 60. Well, when is 0 equal to 60? 0 is never equal to 60, so that means that this system has no answer. So there would be no solution to this system. On the other hand, a system where you would end up with 0 equals 0, what that's telling you is no matter what number you type in, since the variables would be gone, or sorry, no matter what number you substitute in, you're always going to end up with an answer because 0 always equals 0. And that would be a problem where the answer would be all real numbers. I don't have an example of that there, but it's the same type of situation. It's just instead of 0 equaling some number, we'd have 0 equals itself. Let me just show you quickly on the calculator how that actually looks if I use the matrix. And once I have the first matrix set up, I don't have to reset up the 2 by 3. So I can just go right to the matrix itself and start typing numbers in. So 6, 2, 10, and 3, 1, negative 5. Remember, quit out of there. Go right back in. Go over to math. And then if you want to choose alpha B, you can get right to the double REF. And second matrix A. All right, and here, if you get some long thing where you're only seeing two numbers, you can just arrow over to the right, and that'll take you to the end. But the key thing to notice is the answer on the bottom. And we see 0, 0, and then 1. Okay? And so what's that trying to tell us? That's trying to tell us that 0x plus 0y equals 1, and we know that that can never happen. So anytime you see 0, 0, 1 on the bottom, then you know that that's a no solution situation. For a system that is all real numbers, you'll see 0, 0, 0 on the bottom, which will always happen because 0x plus 0y will always equal 0. So that's another option using the calculator to do these problems.